guys, this is Josh Kunle. So we want to see how we can cover parts 1 to 3 in one video, so we can advance from that. So literally everybody can be picked up from wherever to where they can defend something before we go ahead copying and pasting codes. Okay, so we can literally defend whatever it is with John tomorrow, okay, or whenever. All right, so this part 1 is about assigning the pins. I mean, very simple stuff. Assigning these switches 9 to 0 to this LED lights on the top of it. Okay, in fact, I don't even know why that is not a default. Okay, so but basically that's what it wants to do. So you can do that one line after the other this way, or basically use this code here, okay, this part of the code, to assign them as a group. Okay, everything from library EEE to this comment to this is just basically copy and paste gibberish. Okay, they are usually repetitive. Okay, they're just telling you where some of the things should go, some of the natural default directories and things like that. Okay, so of course this is entity part 1. This name has to be part 1, okay, for this code to work. So this code has errors intentionally. I think it's intentional. Okay, and I think the 2 errors there are this space between these 2 hyphens. This is supposed to be a comment. When there is a space between the hyphen, it reads it as something else. VHDL reads it as something else. Okay, so you need to close up this gap, and then there needs to be a colon here. When you say end behavior, there needs to be a colon here. Okay, but at the end of the day, this is what you have. Okay, so you see this gap is closed up here. You see we have the colon here. Okay, unlike what you have in this. Okay, so when you do that, what it does, and the comment explains, a simple entity or simple code, VHDL entity or VHDL code, that connects the switches to the LED red lights. Okay, simple entity part 1 IS. Then you type this down. 9 to 0. Of course, I showed you 9 to 0 just there. You know what that is, anyways. So that's 9 to 0. Okay, and it says here, you need to keep this in mind, that it says here, watch this, that just like the DE10 light, which is what we have here, this is light literally, so it has switches 9 to 0. That's how the DE2115 has 18 switches, which is 17 to 0, and this is the image here. Of course, I don't have it in my room, so that's the image there. So what else? Yeah, so basically you copy this and paste it, so you can explain to him that what this does is that it assigns this, it means literally written here, so okay, it assigns the switches to the LED lights. That's the end of part 1. Okay, now let's move to part 2, and this is basically how you're going to do it. Okay, well, let's do it. Oh yes, we need to do it. So open Quartus on your laptop, or okay, while this is running, well, it's fast. New project. Okay, new project. Next, I've got my license already. I want to put this on the desktop so it doesn't overlap with something. So I define that to go to my desktop. There's a file I've opened for Telegram. Okay, so we can learn. Okay, come on, zoom. Right. Well, that's, yeah, Quartus Telegram. Okay, that's where I want it to go. So select the folder. The name has to be exactly PART1. Okay. If it is not that code is not going to work, because this is the name that is specified in the code, in the entity, in the VHDL code. So you click next. So just like Verilog is to SOC at Alex's classes, VHDL is to DESD for John's classes. Okay, so next, and you don't have anything else next. So you got to define your board here. Okay, I only have max 10. I think there's something I need to do to my Quartus to make it accept or display DE2115, okay, which I've not done. I don't know how to do it. Okay, that's why I've not done it. Well, some people do, I don't know. So finish, next, finish. Okay, so while that is running, That'll take like 30 seconds. Let's cover some gap. Now, next, what you want to do here, okay, in part 2, we're going to demonstrate part 1 in quarters, but while that is loading, part 2 is talking about, it's 5 minutes already. So part 2 is talking about a 2-to-1 multiplexer, okay? Yeah, okay, so, and this S is what influences the X and the Y. It's just in between them, okay? So basically what it wants to do is here in the code, okay? This is lab 2. So basically what it wants to do is when S is 0, it displays X, okay? Let's see that. There's somewhere that explains that literally for us, okay? So when S is 0, the output M is X, and when S is 1, the output M becomes Y. There's somewhere that says that literally, okay? Yeah, I think that's it. Yeah, if S is 0, yeah, that's it. If S is 0, the multiplexer's output M is equal to X, and if it is 1, the output equals to Y, okay? So this is like one step more intelligent, unlike just zeros and ones as your answers. Your answers are actually variables, so to speak. Okay, so if you have to further expand this, you have to write each possibility of X of 0, 1, and juggle it, permutate it around like that. So that's it. And what we're doing here is a 4-bit 2-to-1 multiplexer. Okay, what does it mean by 4-bit? 0, 1, 2, 3. Okay, 4-bit 2-to-1 multiplexer. Okay, all right, so that's it, 2 variables X and Y. So now, so that is what part 2 is, the 4-bit 2-to-1 multiplexer. Is there a comment here? No comment. You can put your comment to make your code look peculiar to you, and the way you do that is by 2 dashes, okay? And the way you do that in Verilog is by 2 slashes, but here you use 2 dashes like this, dash, okay? And then you put your comment. It's going to be commented out. So, but in Verilog it is slash, by the way. So that is what this is doing. Now you see here that we have switched, watch this, to 17 down to 0. So definitely that's going to work with this kind of board. This DE, this kind of board is what this is going to work with. D12015 is what that is going to work with. So, so that is that. So watch this. The same thing like that. Then part 2 IS, then port. The same story, just like this, okay? But now it's 9 to 0, but now it is 17 to 0 because we need an extra switch to do something. So this is still the same thing. End of part 2, architecture, behavior of part 2 IS is this. Now process switch, okay? Now you pick the switch 17, which is going to be somewhere around here, okay? This switch 17, what it's going to do for you is that when it is 0, this LED 3 down to 0, the 4 LEDs here, which is, okay, basically on the top 1, 2, 3, 4 here, it's going to be controlled by these switches 1, 2, 3, 4, okay, which is like the default thing you should do. But then when that switch 17 is 1, the same LED 3 to 1 will be controlled by switch 7 down to 4. So basically these 4 will not be responding anymore. It's somewhere here 7 down to 4 that will be controlling this same 4 switches, this same 4 LEDRs rather. So that's basically what you want to do with that. And that's the end of part 2. Okay, while we're doing that, this guy is ready. Now watch, this is how you run both part 1, part 2, whatever part you want to run. New VHDL file. Okay, you can double click it or click that and click OK. Then you've got this. So then you go to this that I'm going to post on the page now. You copy it literally from here down to semicolon at the end. Copy that, go to quarters, paste it here, and am I ready to run? Yes, I think so. So then you go here and you click run. Okay, do you want to save? Yes. Okay, then the same desktop quarters telegram that I created for this, same name, part 1, don't touch it, just save, and it's going to run. Okay, so I'm very confident that it's going to run successfully. So while it is running again, we need to go back to our lab 2. Shut that down. Okay, so yeah, so basically this is how you do your lab 2. Create a new quarters project file, include VHDL file for the 4-bit wide 2-to-1 multiplexer. 4-bit wide because you remember 0 to 3, okay, controlling switch 0 to 3. Then at the other condition, 7 to 4, sorry, 3 to 0 is what I should say. So 7 to 4 will be controlling the same switch 3 to. So because that's 4-bit, so of course that is why it is a 4-bit. That's the name. Where's the name again? Yeah, so that's why it's a 4-bit 2-to-1 multiplexer. Where's that written? Yeah. So here, include your VHDL file 4-bit 2-to-1 multiplexer in your project. Okay, so switch that. That's what all that code is doing. So let's move to part 3. Okay, it's 11 minutes. Let's move to part 3. So let's see how our guy is doing. Okay, good. So zero errors, 13 warnings. So the next thing you need to do, please note this. In order for you to get this into your DE15, DE2115 to work, what you need to do is to literally import something that will make quarters instruct this, okay, to send certain signals to certain pins, okay. And to do that, you will need to go to your quarters and import this. Go to assignment. Okay. Well, let me just show you where it says to do that. Yeah, here. So it tells you literally include the project required pin assignment for your DE series board. Okay, as discussed in part 1, you did the same thing in part 1. Okay, so let's go do that. In assignments, import assignments. Okay, now there is this file that you need to have, which I think I'm going to paste to us also. Quarters. Where is it at? Come on, yeah, that's it. So well, you're gonna find it. So DSD, come on, where is it at? Assignment. Okay, oh yeah, I remember. So here's where I kept it. So it's gonna look like this. You see it? D2, that's it for that pin. Okay, you double click that. Okay, okay it. After doing that, then you run it again. Okay, after running it again, then you go here, processing, or rather tools, please, tools. Okay, and then you click the programmer to program your DE12. In this case, it's DE10, your DE2 rather, 115. So so yeah, so you go there to select programmer. You know what I'm talking about. So you go there and you select that, and then this can begin to respond to you. So 3 steps: your VHDL code, okay, VHDL code here, then your assignment, and assignment you import it, which I'm going to send. Then finally you then put it. Now there is an error. Okay, why? Because can't fit into design device, because I remember in the beginning, of course it's still here, this is max 10, and I went to import an assignment for a different board, so it's not going to work. Okay, so that's because I didn't select the cyclone from the start. I told you I could not. So that's it. You run that, then you put it on this board. Okay, so that's that. So part 3, man, I probably should stop this already. Okay, so let me just, I probably should just upload part 1 and 2 already, because the same principles we're going to run through. So you put this into that quarters, is going to run also. Okay, so yeah, let me just quickly do this. So switch 71 is 0. Yeah, we've explained this. 3 down to 0 is controlled by switches 1 to 3 to 0. But in the second condition, the same red output is controlled by 7 down to 4. It is what controls it. I mean, the Buddha can explain this better, but I don't know if they could just explain better on the group. Okay, so that's just how I understand it. So let me stop this because we can digest this. So I think that should be all. Yeah, for 1 and 2. That's all for 1 and 2. Let's break it. Thanks, guys.